This is Santiago Torres. He is a PhD student of mine. And one thing that happens with PhD students is, in some ways, they're like, you have a baby in the beginning, and the baby you kind of like have to take around everywhere, and then they become a little toddler, and they follow you, and then they become like kind of a semi-rebellious preteen, and then afterwards they kind of like chill out and mellow, and they're like a completely independent human being capable of doing everything you can, and often more. And Santiago is at the last stage here, so the most useful thing I think I can do in this talk is to just step out of the way and let him do his thing. All right, so Santiago, please.
Hello. I was introduced. I'm a Mexican PhD student. I'm studying at NYU. And I've been dedicating most of my 20 years old on software supply chain security. I started like 5 years ago, looking at this problem space, and what I want to have you guys carry out on this out of this presentation is this 4 things. First, I want to not convince you, but show you that software supply chain security is an up-and-coming problem, and it's causing like very devastating compromises all across the industry. I also want to talk about the in-toto, which is I think it's a great solution to start addressing these problems. Then I want to talk about how is in-toto being used today, so just to give you a little bit of inspiration on how you can use in-toto to protect your software supply chain. And finally, to close things out, I want to make a public call on how you can contribute if you're looking for a good open source project under the CNCF umbrella, that you want to participate and start making tickets, adding code, getting yourself introduced to the open source community, then well, in-toto is the perfect place to start. So, when we talk about software supply chain, or like supply chains in general, we usually think about the metaphor of shipping things out. The eventual goal of a supply chain is to get things to an end user, to a consumer, to somebody out there that's trying to use a product. Now, when we talk about software, probably everybody here can recognize all of these logos here, and maybe can I get a show of hands of how many people think that their software is similar to this, maybe a little bit more convoluted, but you can recognize that maybe you have a version control system, you have a build farm somewhere, you probably package things out. Maybe since this is the KubeCon CloudNativeCon, we are talking about instead of putting a Debian package, you probably put a container image out in Docker Hub, or you probably make a whole cloud native application bundle and you ship it to the users or host it yourself. You also may have a CI/CD system that's constantly testing and running different types of evaluations on your source code, maybe on the resulting binary if you're doing some sort of static analysis of binaries, memory leaks and whatever. You can do all of these sorts of things to your pipeline to produce better and more trustworthy software. Now, even with this unopinionated, very simple, almost cartoonish supply chain, we have compromises that can take place. People can hack into the version control system, and they can replace, for example, the pseudo-random seed of your VPN or of your IPsec stack, and suddenly they can decrypt all of the conversations that are happening. And as you can see, because I'm flashing these things out quite fastly, this is not an isolated incident. This happens a lot. And this was just for the version control system. People can also hack into your build box, and they can introduce backdoors. There was a very big event. I think it's maybe 5 years ago, Xcode Ghost. Somebody published a backdooring version of the Xcode SDK, and all of the iOS apps that were built using this backdoored version of the SDK had the backdoor themselves. And this eventually flowed all the way to the App Store, and people that were consuming this backdoored version of the iOS apps were compromised themselves. This is a very big blast radius. This is a very impactful way to compromise many users in different environments. And well, this is not an isolated incident either. Now, we're starting to see a trend here. You can also hack into packaging. You can hack into Docker Hub. You can hack into Red Hat. You can hack into pretty much any package repository that you can think of. And you can get things such as, for example, phpMyAdmin or the Azure Cloud, in which you compromise certain parts of the mirroring infrastructure just to get yourself into certain specific demographics. In the case of, for example, PHPMyAdmin, they hacked the South Korean server. This meant that they were able to do certain things with geopolitics and have certain types of impact into the users of that specific mirror. And well, there's other things such as testing infrastructure in which even though the testing, if the testing is disconnected from the main pipeline, you can have impactful things such as lack of compliance, debugging builds that are shipped to users. And something that I want to be clear about is, when I'm sliding all through these things, I'm not trying to shame anybody in the industry into saying like, hey, you made a mistake in your software supply chain, and you should be ashamed of yourself. The point that I'm trying to make here is, we're stopping here. There was a 4-node software supply chain, and I'm sure that many of you were like, oh, this is so silly, this is so simple. And there's so many avenues of compromise. All of them have a very big impact on users, on your reputation, on your budget, on your IP. And if we make things a little bit more complicated, then worse things can happen, or it's easier to like lose track of all of what's going on. So this is why we want to address a problem. This is why the problem is so complicated. This is why it's so difficult to fix. Now, I know that many of you out there are thinking, well, you can probably use git commit signing, and you can protect your version control system. That's a great idea, and I think everybody should be looking and striving to like having integrity checks over your version control system. You can also have things such as reproducible builds or TPMs and verifiable compilers, so you can have some higher degree of assurance in your build system. You can have things such as TLS or GPG or TUF in such a way that you can have a higher degree of resiliency and high assurance case for your package delivery. And all of those ideas are great. I think that's a great approach. I think that's a great use of point solutions to fixing the problem of software supply chain. But this is an in-toto talk, and you wouldn't be surprised if I'm going to tell you that this is not the end of the story. Now, I took the liberty of deleting a bunch of devils out of the picture that we had initially, and there's a couple left. This raises a couple of questions. One of them is, well, even if you have a point solution, how can you be sure that this point solution is being followed? And if that point solution is being followed and you have a product or an artifact that was created during the, I don't know, for example, the VCS step, is that specific artifact the one that's being shipped into the build farm? Or is it any other? This raises questions about the supply chain integrity, lack of compliance, and any other way of representing this flow of things throughout the supply chain. So, well, what we want to do with in-toto is we want to do 3 simple things. We want to describe what needs to happen in the software supply chain. We want to describe these steps, these 4 steps, or these n steps in any of your particular supply chains in your pipeline. We want to also define who can partake into these operations in the supply chain. We want to say, for example, that only my build farm should be building and doing nothing else. It shouldn't be touching source code. And finally, we want to make a tight linking between the artifacts as they flow through the chain. We want to say the version control system produces sources. Those are the sources that should be input into the build farm. And the build farm builds a binary foo, and that binary foo is the one that is eventually going to float into the packaging or to my container or into any way that I'm going to release things out. Now, well, this is not a Latin class, but you may have guessed that in-toto means that. In-toto means we want to protect everything as a whole, from all the way to the left from the version control system, or maybe even design principles, and all the way to the right into the deployment, consumption, distribution of our software artifacts. So how do we do this? We're going to do this with 2 pieces of information. The first one is called a in-toto layout. The in-toto layout has precisely what I was describing earlier. It has a series of steps. You essentially declare, well, there needs to be a version control system, there needs to be a build farm, there needs to be a packaging step, and there needs to be a CI that's somewhere in the space. Then you want to define who can partake into these activities. You can say, well, Aaron is the one that's in charge of packaging, and Bob is the builder. Is Bob the builder? No, that's Carl. And Carl is the builder, so Carl should be the one that's building things. I am actually surprised Bob's not the builder. And finally, we have the third property, which is registering artifacts who can create what and who can consume what, and how do these things link together. If Carol is the one that's building, Carol should be reporting what she's taking in from Bob, the version control systemist, and producing and Carol should also report what's the binary that's produced. And finally, when the binary that is produced by Carl is being packaged or put into a container image or any type of distribution mechanism, well, the errand should report what she got in and what she produced out of this. With this, we have a very tight linking. We're actually building a software supply chain, and let me emphasize, a chain of things that flow together. So finally, we want to also declare an authoritative figure that says, well, this is what needs to happen. I am the project owner. I am the project manager. I am the BDFL of an open source project. I am the top of this project, and I'm going to say with my signature and my rubber stamp that this is what needs to happen. And whenever you want to verify this specific deployment or this specific package, you want to trust me to tell you what needs to happen. So that's one part of the story. Now we know what needs to happen. We know that all of these operations need to happen in a certain fashion. All of these specific point solutions must be in place, and things need to be linking together. We also have participation recorded in our layout. Now we need to know what happened. Knowing what needs to happen is only half of the story. So the other thing that we have is, or that you need to use when you're deploying in-toto, is link metadata. Link metadata, think of it as in the old school rubber stamping of usual supply chain operations. You take something in, then you perform your step. You take a couple of bolts and build a car door, and then you pass it over. So you create a rubber stamp record of what you took in, what you created, and you pass it on later down the chain of custody. So in the in-toto world, you do this with the link metadata. These are basically records of all of the operations that happened. And well, the rest of the story is, well, you want to make sure that what needs to happen matches what happened. So you take your deployment, your package, your anything that you're really producing. It can be a deployment YAML for all that matters. And then you start walking back the paper trail. Using all of these attestations, you can start checking that the actual supply chain steps were followed. And then you take a look at the policy and say, well, is this actually what needed to happen? And if it did, then everything's good. If there was some breakage in the linking, then something happened, and you can fail verification, you can tail a sysadmin, you can gate out the admission. So this is all nice and good. In theory, this should work. But we're an industry conference, and we're probably wondering, well, how can I make this deployment work in my specific configuration? So in-toto has a bunch of deployments out there. We are actually protecting you if you're a user of Datadog, like many of these logos here. All of the integrations are being tracked all the way back to a developer using a hardware token in the Datadog offices. And there's other deployments by, for example, Microsoft has a CNAB test deployment. CNAB is the Cloud Native Application Bundles. They want to be able to have you track all the way from the version control system or all the way to the left until everything gets back into a Cloud Native Application Bundle. Now, of all of these examples, I was thinking that probably the one that you people are more familiar with is, again, raise of hands, who here uses a pipeline manager such as Jenkins? I'm actually glad. So you can have Jenkins be a pipeline manager, and you can have a gradual rollout of in-toto in such a way that you tell, well, Jenkins, anything that you do in a stage, just create this rubber stamp record, ship it up to a metadata server, and then finally, before I admit any artifact into my cloud, I can gate it, and I can check that the policy that somebody wrote actually followed everything that Jenkins and outside of Jenkins was expecting to happen. So you have operations that happen, rubber stamps that flow into a metadata server, then finally an admission controller enabled by in-toto sitting in your cloud that at the time of admission, it's checking that all of the policies that we spoke about are actually being checked. Now, to use the Jenkins plugin, you basically have to add this line and tick a box in your Jenkins application. And then you have to configure a couple of things around. You have to tell it what's the name of the step. You need to tell it where's the signing key that you're going to use to sign for this specific rubber stamp. And you finally need to tell it where to store this rubber stamp. In this case, I think it supports even Redis or etcd. You can send it to a random CRUD server, and most likely soon you will be able to send this to a Graphias storage server. Now, using the Jenkins plugin, you get a bunch of nice deployment benefits. The first one is that every artifact by the artifact manager in Jenkins is registered for. You know where it came from. You know which specific node produced it. So if there's anything that was fishy, you can actually nail it back down to a specific box or a specific container that actually performed this operation. You can also have, this is so small. You can also have the verification of admission time, which saves you a lot of overhead on terms of verifying the software supply chain elements with a scanner or something that's actually sitting on your box and may be missing something. You can also have things that are sitting outside of your cloud. Some tools like kubesec can be scanning your deployment files, and they can be contrasting them with your containers. So you have things that very tightly tied together. You have your container image supply chain, and then you have your deployment configuration supply chain. And both of them meet in the admission time, and you can get both things together. You can also save yourself time. Instead of calling HTTP webhooks at admission time and waiting for latency to be affecting your deployment, you can preemptively start doing these checks and saving these rubber stamps on the server as they are created. You can also have things such as better auditing processes, which is something that I spoke about. And you can finally, oh, wait, this is maintenance? Yes. So when you finally deploy this, you basically need to do these things. And I think this is a very good picture on what you get for free by doing this type of tightly auditing of your supply chain. Because you defined everything on a single source of truth policy language, you need to introspect into your software supply chain, even if it's a gradual rollout and you just want to protect the specific steps. It doesn't force you, but it makes you look back into, well, if I need to update the Jenkins file, do I need to review the policy on how things should be done? Do I need to review whether my kubesec integration or my vulnerability scanner should change consequently when I change the Jenkins file? Or if I'm rotating personnel, should I be rotating keys around? Or if I'm adding new elements to my pipeline, should I be going back to somebody or a security team to actually gate it and tell me, hey, this is good to go, or you should be considering changing this pipeline this way? So that's a free bonus. You get a very tightly defined process that you can actually and reasonably update and improve as time goes by. Now, we recently integrated into kubesec. You can basically do that. You can talk to kubesec and tell it, hey, give me a rubber stamp version of in-toto, of your scan using in-toto metadata. And you can use a kubesec key to know that they are actually the ones that are performing the scan. This will give you a lot of insights in the future, because you can walk back and say, hey, if my scan score is changing, I can go back and check that when each scan was run and still confirm that it was kubesec, the one that was running all of the scans. There's other meta information that I think will be added into the rubber stamped version of the link metadata on the link metadata for kubesec, such as version numbers or particular score values that are going to be interesting when you want to do further introspection into your deployment files. Now, how did kubesec integrate in in-toto? We basically did a 50-line diff using the in-toto Golang library. And I'm telling you this because probably you're working at a company that does vulnerability scanning, and you probably want to create in-toto attestation so as to improve the quality of your product, or to add another offering that is a distinguisher between you and the people using it and your competitors. And so we added that. We added a 50-line div. We basically just added a bunch of, a big security plus just by a small code change. So now, the insight that I wanted to have here is you can either be a producer of in-toto metadata for your customers that want to have a higher assurance case for your in-toto deployment, for their in-toto deployment, or you can be a consumer of in-toto metadata, and then you can start using in-toto metadata inside of your pipeline. For both cases, I think they are a big win for the overall supply chain security ecosystem. Now, finally, just to close out, I wanted to make a call to contributing. I think there's a lot of interesting things that you can do to help with in-toto. We have 3 implementations. We have a Python implementation that is probably the most mature one. You can check our roadmap. We have pretty much full spec compliance. We have most of the features in, and we have a bunch of production deployments with it. So it is probably the one that you should be looking at if you want to play. But something that I was thinking that we could use from new contributors is to make a deployment test. You want to set a dev environment from scratch without knowing much about the project. And you will surely run into things such as, well, I don't think the docs are clear, or you know what? I tried these things and they didn't work in a specific macOS with Brew installation, or I was using Windows subsystem for Linux. And all of those things are useful because we want to make it usable for everybody that wants to protect their software supply chain. If you are more interested in other languages such as Java or Golang, those also have a roadmap, but they are a little bit behind in features. So if you're excited about a feature that you think that should be added to those languages, then by all means, take a look at the issue tracker, or take a look at we have a section in the README of the features that we are thinking should be added next. If you want to just go and try that, I think that would be very useful. We have a Slack channel in the CNCF mailing list. We have a IRC channel on Freenode if you also want to drop by there. And we're pretty welcoming to pretty much anybody in the ecosystem that wants to either play with in-toto, develop in-toto, or more. Now, the implementations of in-toto are not the end of the story. We also have a bunch of tools out there. I mentioned there's a Jenkins plugin that you can use. You could work on that if you're somebody that's very knowledgeable of Jenkins plugins that wants to add more features, or probably make it better integrating to your type of pipeline. Then that's also a great way to get started. We have a kubectl plugin, kubectl, depending on who you ask, or kubectl. But that plugin, for example, lets you scan your deployments on client side. You can also hack on that. I think it's also a good way to start if you want to run verification without blocking your deployments on production just yet. And the kubectl plugin, as a matter of fact, is the same code base that goes into the admission controller. So you can get code in there and consequently making the quality of the admission controller better. And then we have, we have other ways to contribute. Even opening an issue is fine. I think don't be shy of saying, hey, I didn't understand the docs because I think my deployment doesn't fit your way of thinking. And I think it's either on our fault and our design needs to consider something else, or maybe it's our fault in our docs, and our docs aren't clear, and it doesn't give you enough hints on how to actually deploy it on your ecosystem. So to wrap up, I hope I convinced you the software supply chain was a big problem that you need to start thinking of and trying to address as soon as possible. I hope I convinced you that in-toto is a great tool to do so. And I hope that you are excited to either integrate in-toto in your tool, protect your tool with in-toto, or making the in-toto ecosystem and tooling a better place. And thank you. Try it in-toto. Of course.
Does anyone have any questions?
Yes, so An issue I find is that you're integrating something at the CI stage that only gives you the feedback at the deploy stage. Hopefully,
can you
have
repeat
a fast.
or rephrase your question? Sorry, I got lost.
So in-toto runs at the CI stage to add those checks, but it will tell you if you fail those checks only when you try to deploy, right?
So you can check at any point you'd like. We think that it's mission critical to check before deploying or admitting a container. But if you'd like to save yourself time, save yourself headache, and do verification earlier on, you can totally do that. The framework is not precluding you from doing so. Something that I think is another great area of improvement is we have all of this like verification left, but having something like an integration with a service mesh in such a way that you can revoke, for example, an attestation for a vulnerability scan, or revoke an attestation for a sign-up from a release manager, things like this, so in such a way that you can spin down a container that is related to that supply chain. That's another great way to go. But as I said, in-toto as a whole, so we want to be able to not only attest, but verify at any point in the supply chain in such a way that's flexible and powerful, with powerful semantics to allow you to do that.
Apologies if this was at the beginning and I missed it. How do you lock down the management of the key server so that you know all the keys for all the people and all the steps in there, that system is secured? Okay, so the public keys of anybody that's related to an activity are stored on the layout. Now, how do you distribute those private keys to the specific stakeholders? We consider that a little bit out of scope. We have a different key management support. We support GPG keys if you're, for example, Debian does that, so we need to do that. We also support all of the families of PKCS, V, X. So if you have a PKI solution that you can export those keys, you can also do that.
How do you ensure the availability of in-toto so that it doesn't become used as in itself a denial service if it's down and therefore you can't deploy because you can't get to it? What happens in those scenarios?
That's a great question. It depends. You get, the tool itself will basically tell you something's wrong. What type of action do you take in? I am a security guy, so you should not deploy that. But I know that, for example, the Debian transport for reproducible builds, as a matter, it is a fact that there's things that aren't reproducible. So you're running total verification over those packages, and it's going to fail just because of the sheer nature of them being unreproducible. So you can flick a switch, and you can say, instead of just gating it out, send me a warning or print a big red banner that says you should be digging into this specific package. You could do so in the admission controller. I don't think there's code to do that just yet, but I think that would be, for example, a great first feature.
Does Toto provide insight into dependencies going into the whatever is getting built?
I'm so glad you asked that question. I'm so glad of all of the questions. They're very good. in-toto is a tool that's also recursive. So you can pull in in-toto metadata from your dependencies. The ecosystem is a little bit early, so there's not a lot of metadata around. But you can actually do you say you have a layout that says, well, I am going to pull in all of Debian. So let me pull all of the metadata for Debian and introspect into their metadata as well. So it's secure totals all the way up in some way.
So yeah, and I'll even add one more point to that. So in the future, when the next release of Debian is built, you'll be able to look at things like when this package was built, what was the software supply chain for the compiler that was compiled last time to do this, and for the operating system kernel and so on. So you do get very much this, you can imagine even doing this across projects where, there's pip installed packages that were built on a Debian environment that had this and so on. Any other questions? Oh, great.
So do you have any sort of like centralized distribution of some of these things? Like, I could imagine I do a lot of Java development, so there's Maven jars all over there that is just have, supply chains that, you would need to have insight into. Is that kind of like is there like plan for centralized distribution of some of these information?
I cut half of that. Could you rephrase it? The things I think the speakers are pointing that way.
Are there plans for a centralized way to get all this metadata?
That's another great question. So I think tomorrow, or right now, unfortunately, there's a talk by the Graphias team in which they are going to mention that in-toto can be input into a Graphias metadata server. So you could store all of this metadata in a central location, and then you can query it on demand. In-toto itself is not designed thinking of a specific transport, because we knew that many supply chains use different types of transports. And oftentimes we get people that come to us and say, like, hey, why don't we put this on a transparency log? And it's like, that's a great idea as well. Or why don't we put it on the blockchain? It's like, go do that too. There's nothing stopping you from storing it on different spaces.
You showed a Jenkins integration on it's kind of a bit of magic what's happening behind the scenes for integration with other CI systems. What would be the steps to be able to integrate Toto in stuff like GitLab CI, where each job is its own container? You can't really wrap that job with a wrapper that checks what's inside. Like you have to integrate Toto into the image that runs the job, which makes it it's more maintenance. So I'm curious if you have seen, if you've taken those use cases into account for the future integrations through a CLI or something like that.
I think I didn't follow you, sorry.
So to use in-toto with CI systems like GitLab CI, Circle CI, all those new CI systems use a container per pipeline or per job inside the pipeline. So right. you can't really integrate other stuff around it. If you want to run something, it needs to be inside that container.
So, well, that is another good question. I think that there's no technical limitation to that. As a matter of fact, the Datadog integration, they built what they call an untrusted CI. They are running everything on GitLab runners that spin containers that then die. But you can assign them temporary keys, and you can also set up we call this in-toto record and start and stop. You can basically record the state of the ecosystem or the container file system before it runs. Then you let the whole thing go, and then you can record the rest, and you can diff it. And you say, well, this layer is what happened. It's similar to like a Docker run type of approach. But then those are the products that you can then ship out.
Okay, thank you.
All right. If we don't have any more questions, let's thank the speaker again.